Welcome back to class, students. Hope you're ready to start a new unit about inequalities. In this unit, we're going to look at solving, graphing, and writing inequalities. So what exactly are we talking about?
Most of us have probably had to do it, trying to raise money for our schools, our clubs, or for me, my research teams. You may find yourself washing cars, selling cookies, trying to convince your family they really need another magazine subscription, or maybe pledging to bike, run, or like I'm going to do, swim a certain distance. I'm raising money for my school. The challenge is to figure out how far I need to swim, but I can do that with an inequality. I need to raise more than $150. I've got pledges of 75 cents for every lap I swim. Plus, one person decided to pledge $10 no matter how far I go. Let's say that X is the number of laps I swim. To make more than $150, I need to find the X that makes 0.75X plus $10 greater than $150 true. A few simple calculations, and I need to swim 187 laps or more to make that money. I better get going. That's another reason math matters.
All right, so that was a good example of the types of problems we're going to be solving in this unit. So go ahead and pause and add this to your table of contents. And we're going to look at how, in this lesson, how we graph and solve one-step inequalities. We'll start small. All right, so we're going to start by looking at what an inequality is and how it's different from an expression and an equation, which is what we were dealing with before. Expressions have variables and numbers and at least one operation, and they could even not have a variable too. So here's some examples. Equations, or math sentences, as they call them when you're younger, have two expressions, like one on each side, and they're separated by an equal sign. So equations have equal signs. And now we're going to talk about inequalities. So they're like equations, but instead of equal signs, they have inequality symbols, these guys right here. And they describe, the biggest difference is they describe a range of values instead of having just one answer. All right. So when do we come across inequalities, and what the heck do they mean anyways? Well, here's a couple real-world examples. We've all seen like a truck sign like that before. So what are three truck heights that could go on that road? We could name some numbers that are less than 10 feet 6 inches, like a 9-foot truck, an 8-foot truck, a 10-foot truck. Could a 10-foot 6-inch truck pass? Yes, because it says nothing over that height. Let's look at the speed limit here. What would be a speed legal on that road? 40, 42. Believe it or not, you can actually get a ticket for going less than the speed limit if you're going so slow that you're causing like hazard to other drivers, but let's pretend that's not true. So pretty much anything less than 45 would do. Is 45 allowed? It is, because it says that's the limit, so nothing higher than 45. So hopefully you've seen these symbols before, but a lot of people struggle with naming them. So if I pointed to a symbol, could you tell me what that's called? So if that's something you struggle with, this unit's a good chance to get it right. So go ahead and pause, copy these down, and you should be able to point to a symbol and know what its name is, not just know which side's bigger and which side's smaller. All right, so back to those examples before, we can see that we can actually represent them as inequalities. And I could use a variable to represent, something like height, is less than 10 foot 6 inches. I could use S for speed. Speed is less than or equal to 45 miles an hour. Sorry, that was a less than or equal to symbol there. All right, so now we're going to do a little elementary school review of how to graph inequalities on a number line, because you've probably forgotten. So inequalities don't represent one thing, they represent a range of values. So like you go to an amusement park, it says you must be at least 48 inches tall to ride this roller coaster or whatever. I could use this inequality right here to represent the height. So what are some numbers that make it true? Well, anything bigger than 48, like 50, 52, 60, etc. What are some numbers that would make it false? You know, sorry, my kid who's 44 inches tall, you can't ride. Neither can this 40-inch kid or even this 47.5-inch kid. But that's when you go to the bathroom and you stick some paper towels in your shoes, right? So many numbers can be included as true in that situation that we're not going to graph it with just a dot on the line. We can actually graph it with a big old arrow on the line. Okay? So if I was trying to graph n is less than 3, that means I want all the numbers that are smaller than 3. So I would have an arrow going away from 3 to the left, showing like, hey, all these numbers work. And I'm going to use an open dot saying not 3. I'm not including 3. If I wanted to graph n is greater than or equal to 3, that means I want 3 plus all the numbers bigger than 3. So I'm going to shade in the circle of 3 showing I'm including 3, and I'm going to do an arrow going to the right. Go ahead and pause and write this down. We want an open dot for the greater than and less than symbols, or less than and greater than. We want a closed dot for less than and equal to and greater than and equal to symbols. And we're going to use arrow to include all the possible solutions to the inequality. All right, so back to that one. How would I graph it? Well, h is greater than or equal to 48, so that means I want 48. 48 inches tall is cool, and then I want all the numbers bigger than 48. So I'm going to have an arrow going this way. You don't need to put every number in the world on the graph. If you just put like 2 going in each direction, in addition to, you know, the one that's in your inequality, that's fine by me. All right, so watch me try a couple. All right, if I want to graph x is greater than 2, I'd go like 2, 3, 4, 1, 0. I look at my notes, I see that as an open dot, and I'm going to the right because I want all the numbers greater than 2. If I want to graph x is less than 1, I'd go 1, 2, 3, 0, negative 1 over this way. And I'd say, okay, I'm going to start with an open dot here because it's a less than symbol, and I want all the numbers less than 1, so I'm going to go to the left. All right, if I want to graph x is less than or equal to 5, I would go 5, 6, 7, 4, 3. I would use a closed dot because I'm saying, hey, 5 is in on this too, and I want all the numbers that are less than or equal to 5. So 5 and all the numbers going this way. Last example, when you're dealing with negatives, just remember a negative number line goes the opposite direction, so be careful with that. So it would look like this. I would use a closed-end dot because I'm saying greater than or equal to negative 4. So I'm saying, hey, negative 4 is in on this. And then I'm going to do all the numbers that are bigger than negative 4. Go ahead and pause and copy these down. All right. So don't worry about using a ruler or anything. We're not going to worry about it being perfectly straight. So again, we're going to use the number from the problem, and then we're just going to add 2 in each direction. All right, now let's graph this. N is greater than 4, so I'm going to use a number saying, or an open dot because it's not including 4. And then I'm going to draw an arrow going to the right because I want all the numbers that are bigger than 4, but not 4. So open dot there. It's a good idea to draw your arrow above the number line. It helps it be like stand out more. All right, let's try this guy over here. And again, negative number lines run in the opposite direction. So just be aware of that and make sure you're getting that down correct. P is less than or equal to negative 2. So I'm going to start here with negative 2 and I'm going to color it in because it says or equal to. So I want to include that. And then I want all the numbers that are less than. All right, you might have noticed in these examples, okay, or might not have, but when it's greater than, my arrow is going to the right, and when it's less than, my arrow is going to the left. Less than left, greater than right. And as a matter of fact, you can kind of look at that symbol, and you can just pretend like it's an arrow, showing you where you need to graph. So for that reason, go ahead and write this little tip down. And again, that only works if the variable is first. If the variable is not first, then you got to reverse this little trick and go against the arrow. So let's do 2 more quick examples here. Hopefully now it's a little easier now that we have this tip to help us out. Okay, I'm going to say, okay, open dot, because I'm not including 7, and I'm going to use this as a little arrow, and my arrow is going to go this way. And I could do that because my variable was first. Let's do an example where the variable is not first. And this problem's extra weird because it's got negative numbers involved. So remember to run your number line backwards. And it says -1 is less than or equal to n. So you can rewrite it if you want, and go ahead and rewrite it now. And then now we can use it. And just make sure when you rewrite it with the variable first that, see how this is open to the n? Keep it open to the n over here. All right, so I'm going to use a closed dot because it's the greater than or equal to symbol. And now I have this little arrow trick, and I can go that way. Go ahead and pause, grab a piece of scratch paper, and just try sketching a graph for these two. All right, well, that's it for today. So pretty much that was more of a review of what inequalities are and how to graph them. And so when you come to class tomorrow, come with that scratch paper with those 2 that we tried, and then we'll actually dive into solving them and graphing them instead of just an elementary school review. All right, get a good night's sleep, and I'll see you in class tomorrow. Bye.